Okay, here we're looking at the difference between displacement and distance, really. We have a bunch of position versus time graphs, and we're going to try to first figure out which one has the greater displacement. The displacement is just the difference in the final and initial positions. So it's how far you end up from where you started, basically. So we're in all these, we're looking over the whole 10 seconds. And let's see who has the greatest displacement. So here the displacement is 0 because the initial and final positions are the same. Here the displacement is also 0. Here the displacement is 10 meters. It's 10 final position minus 0 initial position is 10 meters. Here, which is where you measure this, delta x is 7 meters, 10 meters minus 3. Here, the delta x is negative 15 meters, because the final position was 0 and the initial was 15. So negative is what you'll get. And here, that's the final position. All this jazz that happened in the middle, that doesn't matter for the displacement over the 10 seconds. If I wanted the displacement over 3 seconds, it'd be 10 meters, but that's not what we want. So 5-meter displacement there, which means our biggest would be C, which is bigger than D, which is bigger than F, which is bigger than A, which equals B, which is bigger than E, because E is negative. So, right, this is only our difference in final and initial positions. That's all we look at there, regardless of what happened in between. Now, if we're looking for distance traveled, we do care about things like turning around, and our distances are always positive. So think of the odometer on your car. It only goes up as you drive, no matter which direction you go. And if you turn around or whatever, it still goes up. As Ferris Bueller learned when he tried to roll it back unsuccessfully. So we're looking for which one went the furthest during the motion. So all of these that didn't turn around, their distances traveled are just the absolute value of the displacement. So this one's the only one that changes. This one, though, had a direction change. So it went 10 meters, and then turned around, it went the other direction 5 meters. So that's a total distance traveled of 15 meters. So F and E are equal, and they traveled further than C, which traveled further than D, which traveled further than A, which equaled B. Both of those went nowhere. So this is our so this is really is the sum of the absolute values of the delta x's, if you want to look at it that way, from the whole trip. All right, that's it.